Hello all, welcome to the topic GPIO port in microcontrollers. So in this topic we are going to discuss about basics of GPIO and about the output states and about input states and how to enable the GPIO peripherals using how to enable the clock of the GPIO peripherals, and we will discuss about what are the registers we are going to use particular port as a GPIO pins, and we will see about what are the additional features for the GPIO pins and what are the alternate functionalities which we can assign to that particular GPIO. So we are going to discuss about these topics in brief. How the device communicate with each other using the communication protocols. In the communication protocols, before we are going to learn about that communication protocols, the first thing is we have to learn about GPIO, which is general purpose input and output. In the name itself it is there. For the general purpose we can use that particular pin as input, or we can use that one as output. These GPIO port pins, in case of different communication protocols, according to that protocol need, then we are enabling that particular other communication protocols as alternative functions to this GPIO pins. Alternative functionality. So all the other communication protocols will be like a alternative functionality of the GPIO pins. So before using this any protocol or to use these GPIO ports also, we have to first enable the clock for that particular peripherals. I will show how the peripheral buses will be present and how to enable that clock setup and all. When I am showing about the data sheet, I will explain about that one. So now let us discuss in brief about the output stage. As we know, the output states will be three types of states may be present. One is high, another one is low, another one is in the floating state. As we know, in these three states, we want the states in be either in high or in low state. We are not interested about this floating state because this is not useful for applications. We are using either high state or low output stage. To set up GPIO pin in either high or low, generally we are using two configurations. One is push-pull configuration. The second one is open drain configurations. Now let us see how the basic structure of output driver will be present. You can observe it here. This is the output driver block. So now as we are discussing about GPIO, so let us don't care about this alternate function block. So this is the main one. So this will be like directly the signal is coming to this output control. So this input is going to both PMOS and NMOS. In general it will be like this. So will be there. And then VDD IOX, then next NMOS will be there. Let it be ground. This one, let us consider this one as output, which will be Vout. The same thing is going to here, and after that this using push-pull, using either pull-up resistor or pull-down resistor, that output logic it will be set, and for protection they are using protection diode. This will be external. Now let us concentrate on this output driver. In the push-pull configuration, suppose I have provided the logic as 0, then it will come as high because this is inverter, and then this is off, and this NMOS transistor will become on. So this will be off means here there is no connection, there is no continuity at here, and here the short circuit will be present for the NMOS. So for the PMOS it will be open circuit. So it will be like Vout will be like connecting to the ground. So in this way we are receiving the voltage, the input voltage 0 volts, we are receiving the output also as 0. In case if we apply 1, then in that case here 0, then in that case this will be on, and then NMOS will be off. So here this will be open circuit, this will be short circuit. So this high voltage will be passed to this Vout. So in that case Vout will be this VDD. So this will be like push-pull configuration. In case of open drain configuration, there will be only one MOS transistor will be present. So in that case, what is the disadvantage is, in case of open drain, there may be chance that some current leakage may be present. So to avoid that one, generally they are using this pull-up or pull-down resistors. In case of push-pull, there will be no pull-up resistor. In case of push-pull, there is no mandatory to connect this pull-up or pull-down, because here we can see there is no chance of leakage. In case of open drain, only this NMOS circuit will be present, so there is a chance of current leakage will be present. So to avoid that one, there is a need of pull-up resistor. This is, so remember, whenever you are using open drain configuration, this pull-up resistor we have to use. It may be internal in the controller, or in case in the controller if it is not present, externally we have to use. How we will come to know whether externally we have to use or not means, we have to see the data sheet. In the data sheet, if they are telling pull-up resistor is present means, then we have to enable that particular register to enabling this pull-up configuration. So as I have already told, the states will be either high or low or floating. To keep the pins away from the floating, we are either using pull-up or pull-down resistors. In case of pull-up, the resistor is one side is connected to Vin, which may be like 5 volts, and then the logic, it will be the output port, it will be connected to this 5 volts. So always the signal will be high whenever I am pushing my switch. You can observe it here, whenever I am closing the switch, then what it will happen here, the logic level will become 0. So it will become 0, and then till this switch has been closed, the logic level will be at 0. After I have released this switch, that means that switch has come into its actual position, then again the logic will be goes to logic high. So in case if we want to keep any port pin as always high and you want to switch that port pin according to our switch position, then we can use pull-up. The pull-down will be opposite. It will be mostly connected with the ground voltage. So here it will be 0 volts. Whenever we are connecting this switch, that means this switch has been pressed means it is connected to this 5 volts. So that time when the switch has been pressed, it will be at 5 volts. If the switch has been released, it will be 0 volts. So it will be always, it will be 0 whenever that switch has been enabled, and that time only it will be high, and then again it will come to 0 volts. Okay. In case of floating means, as for any GPIO pin, there will be some logic levels will be there for logic high, similarly for logic low. If it is in between logic high and the logic low, then it will be considered as floating. Suppose I am taking in my logic levels from 0 to 1.3 volts, we are considering as a logic low. For high, I am considering as 1.8 to 3.3. Let us consider this 3.3 as VDD, or the maximum voltage. So this is high. If it is in a stage of this 1.3 volts to 1.8 volts, then it can be considered as at floating stage. And basic structure of I/O port, how it will be is the same GPIO port which we have seen in case of, see, this is input driver, this is output driver. The same pin we are going to use as input. So here, to avoid these floating points, generally how to avoid these floating points? Using Schmitt trigger, we can avoid this one. Because say Schmitt trigger, it will switch from one logic to another logic whenever it has reached its cutoff, more than its cutoff or less than its cutoff. So this is, suppose, upper threshold, this is lower threshold. So in case of Schmitt trigger, if it is lower than this lower threshold, then it will be changing to the lower voltage levels. If it is higher than this upper threshold, then it will be changed to higher levels. So here they will use mostly a Schmitt trigger to avoid these floating values. And then here data read register will be there. Using that, it will read the data. Next, as I told, to use any peripheral, whether it is GPIO or any peripheral, first we have to enable this clock for that particular peripheral, and then we are going to set whether it is input mode or input or output we are going to select, and then we have to select its configuration, like we want to use in push pull or open drain configuration. Or do you want to set up the internal pull-up? As I already told, in case of open drain configuration, it is mandatory to use the pull-up resistor. In case if it is not present internal to that microcontroller, then externally we have to use the pull-up resistor. And some other microcontrollers will provide the features like GPIO locking mechanism. That means if we want to set as an output, and we have set that particular port pins to some voltage levels, and we want to lock to that voltage levels. Suppose example, GPIO A is there. Let us consider for ease of use, this is 8-bit port. Example for 8-bit GPIO is 8051 microcontroller is consisting of 8-bit ports. Okay. Here in case of STM32 microcontrollers, all the GPIO ports are 16-bit ports. Similarly, there are other microcontrollers are there where the GPIO ports are 32-bit ports is also present. This is about GPIO. Okay. Suppose our GPIO output pin I have configured as, let us take the example of 8-bit. Okay. So 10101100. Like this I have configured its values, and then if I want to lock the mechanism, means after we have locked it, then it will be like we have fixed that values. Okay. And then speed setup. In the GPIO also, port switching from one output logic level to another output logic level, with how much speed it has to switch, that thing will be explained using speed setup. For this there will be one registers will be present to set up with which speed it has to go on. It depends upon the clock also, it depends. Example, suppose my GPIO pin is at logic level 0. If I am switching to logic level 1, then this time is there, right? This time, in case of low speed if we have set, then it will be low. In case if we set the speed as higher, then this switching speed will be higher. So based upon this speed setup, we can limit that for particular GPIO pin, we can limit. That means what is the maximum output frequency we can generate from that GPIO pin. We can set up that limit using this speed setup also. And for that, even with high speed also, there will be like limitation will be present based upon that bus frequency. Based upon that bus frequency also, there will be limitation for the maximum switching speed of that GPIO port. And alternate functionalities. As I told, suppose if we want to use the ADC, all those earlier it will be like a GPIO pins, we have to select that particular GPIO port for the functionality of ADC, or otherwise SPI, or otherwise I2C, like that. Okay. Now let us observe all these in the registers, like what are the registers will be present to set up these configurations. We will see that one using the reference manuals and the datasheet. In our LMS, after day 5, I have kept one more module like STM32G474XX references. This XX means for G474, the different types of microcontrollers you can use the same references. Okay, I have opened this one. Here total 4 documents I have provided. The first one is in brief about the Nucleo G474 board. The second one is this particular controller data sheet. The next one is about a reference manual for that microcontrollers, and then about the schematic of the Nucleo G474 board which we are using, that board schematic. The same thing I have opened in the another tabs. This is a schematic, and then reference manual and data sheet, and then in brief about the Nucleo G474. This is a board which we are going to use for practice in the smart lab. Okay, if you observe the features of this board is having one user LED which is also shared with the Arduino. That means here you can observe these, see these connectors are there, right? These connectors are compatible with the Arduino ports also. And one user push button and one reset push button is also present. You can go down and let us see about our particular board which we are using, which is this one, Nucleo G474 RE board. You can observe this targeted STM32 microcontroller is STM32 G474 RE T6, and this is the user manual. If you click on this, then in the new tab here it will open. Here you can go down and you can just click on that particular target STM32, then you can open the sheet about that one. Okay. So I am opening that one so that I can show the exact board. See, this is the exact board which we are using. This is the top view of that board and this is the bottom view. Here you can observe there is one LED will be present which is LD2. I think you can observe it here. This is the LD2 and this is the user push button and this is for reset. We are going to experiment on this LED only. In our lab session we are going to experiment on this LD2. If you want to see about some more features of this board, then you can go down and you can see about it. Here they will provide the hardware block diagram also. Here you can observe here, this is ST-Link. There are like 2 ports will be present. This second port is the actual where the controller is present and where the port pins all we are accessing. On the top it will be like ST-Link version 3 port is present. This is using to communicate with the system. We are connecting this USB micro B connector using the CN1 connector. From that connector to communicate with our STM32 G4 series microcontroller, we are using this ST-Link connector. We can use the external connectors also, external hardwares if we have, then we can connect using external hardwares also. For that thing they have provided the provision also. Different connectors provision they have provided here, and then using that you can connect. Okay. So if you observe this board, then here till this, here they are written debug, right? till that straight line, it will be like this top part will be like ST-Link connector, and this after these switch pins, after these switches, whatever the thing is present, this is the actual where our microcontroller and these extension pins for that will be present. Here this CN7, similarly CN8, CN9, CN10, CN6 and CN7. Okay, you can go through this documentation and you can observe these connectors also. And then next about data sheet. I have downloaded this data sheet. If you want, let me show. If you want to download the data sheet, then click on this download data sheet and then you can download. Here you can observe this is this controller. The same thing I have kept it here. This is for this series. Okay. So now if you go through this data sheet, then in the starting the features of this particular controller will be present. Okay. While explaining GPIO, I told, right, for the each and every peripheral there will be some clock buses will be present. Now I will show that one. Functional overview. Before this, yes, block diagram. You can observe it here. STM32G474 block diagram has been present. See, this is the entire block diagram for this controller. Okay, let me zoom this one for better visibility. So now let me explain in simple about this block diagram. You can observe it here. This is AHP bus is present. Generally this AHP bus is connected to the peripherals where the high speed requirement is present. If you observe, it is this AHP is connected to the ARM Cortex M4 and it has to connect with the flash and to connect with the SRAM. Similarly to connect with the DMA, and along with this one, this quad SPI also, yes, this quad SPI also will connect. And then in case if you want to connect to the external flash memories, all those will be directly connected to the AHP bus. This is higher speed bus. The full form of the AHB is Advanced High Performance Bus. To communicate with the peripherals, they will use APB bus, which will be the Advanced Peripheral Bus. The AHB bus is faster than compared to the peripheral buses. Now let me show some of the peripherals where they have connected to the peripheral bus. See, here you can observe from this AHP1 bus is present. From there will be interface will be present for the APB bus, APB1 and APB2. Now you can observe this UART, SPI and system config and the timers and wake up external input wake up, all those connected to APB2 bus. And in case of low power UART and the some other timers and RTC interface, all these things has been connected to APB1. Okay, and if you have, let us see where is our GPIO port. See, these are our GPIO ports. Sorry, GPIO port A, port B, port C, port D, E, F and G are present for our controllers, and all those are connected to the AHB2 bus. You can observe it here. This is that line and here, and each port is consisting of total how many number of pins? 16 pins. Port A is also 16 pin, port B 16, similarly till port G 16 pins are there. Now in our experimentation we are going to do with the GPIO port only. So that's why I am not discussing about other timers, UART or ADC or SPI, all those things I am not going to discuss now. Now we are going to discuss only GPIO. So now this port is present. To set this particular port, what are the registers we have to set? All those things also we will see. For that I am opening the reference manual Let me open this reference manual. This is the reference manual for STM32 G4 series. Full G4 series, this is the reference manual. Here let me show. So if you want to know more about your microcontroller and all, then you can go to this reference manual and you can go through this one. So now in our case we are going to discuss about GPIO. So now let me take you guys to the GPIO flash and let us see it here. See, this is general purpose input outputs. Before that, this flash and power control and RCC and clock recovery system, all those things they have explained. After that, it is about GPIO. So now here you can observe each general purpose IO port has 4 32-bit configuration registers. So what are those registers? These are those 4 registers and 2 32-bit data registers. These are the 2 data registers. So total 4 configuration registers, 2 data registers and 1 32-bit set or reset register has been present. Now let us see about one by one and then we will see what are its use. Okay, and apart from these, to provide the alternate functionality, you can observe it here. 2 32-bit alternate functionality register has been provided at here. Okay. So now you can observe it here in the GPIO main features. They have mentioned that output states we can set using push pull or open drain plus pull up or pull down. Okay, and we can set the output data register using these register values, and then for other peripherals we have to use as alternate function output, and speed selection also present. And here one more important thing is, you can observe it here, fast toggle capable of changing every 2 clock cycles. That means to change from one state to another state, at least it needs 2 clock cycles. So what is our bus speed? In the data sheet they have provided, right? You can observe it here. It is connected to AHB2 bus. So this, how much fast we can switch about this GPIO port. To switch from one logic to another logic, it needs at least 2 clock cycles of this AHB bus. Okay. So for generating the maximum frequency from a particular GPIO port, the limitation will be total to generate a frequency 2 clock cycles from switching from one state to another state, to switch back to the previous state, again 2 more clock cycles. So at least minimum 4 clock cycles are required. So based upon this, the limitation will be present. Here they are providing this functional description, the same thing which we have already discussed now. See, this is the basic structure of an IO port I have taken and I have kept in the presentation and I have explained. So this is this output driver, this is input driver. In case of alternate functionality, here you can observe one mux is present. That mux selection bit we are going to set in that register. Based upon that selection bit, it will select whether do you want this GPIO or we want this alternate functionality. The same for the input also. Now this port bit configuration table they have provided. You guys can go through this one. I will directly take to the registers. GPIO registers. I will explain about one by one about the GPIO registers which are required for configurations. Okay. Here you can observe this port mode register is going to set in which mode we want to use that port. If we want to use that particular port pin as a input mode, then we have to set these mode values. Here you can observe this for mode 0 to mode 15. Okay. This is for each port pin. Okay. To use that particular port pin. Now I am taking a whiteboard. Suppose PA5 is present That means port GPIO port A pin 5. I want to set this one as input. Then which one I have to set? This is PA0, PA1, like that PA5. Like that till PA15 it is present. We want to set fifth one. So which will be this one. So this mode 5. These bits we have to set for input mode, we have to set as 00. So these two bits we have to set as 00. What will be that register name? You can observe it here. The register name is GPIO. This X will tell about A to G, that port. So port A underscore mode ER. This particular register consisting of total 32-bit register, right? So 0, 1, 2, like that 32-bit register. In that we want to use PA5. So this pin number 11 and 10, because you can observe it here, this is for 5 to set the fifth pin mode. So fifth pin mode is 11 and 10. So pin number 10 and 11 we have to set. If we want to use as an input, we have to set as 00. If we want to use as output, then we have to set as 01. If we want to use alternate functionality, then we have to set as 10. In case if we want to use analog mode, then we have to set as 11. Okay. So like that, this port mode register is used to set that particular pin in which mode we want to use. Input, output, or alternate function mode, or analog mode. The next one is output type register. What does this output type register means? You can observe it here. That output we want to use as push pull or open drain. You can observe it here. The reset state, it will set that output as push pull configuration. Okay. See here, only two alternatives are there, so only one pin will be sufficient. So that's why from 0 to 15 only they have used it. From 16 to 31 are don't care conditions. Okay, now you can observe it here. For push pull configuration, we have to set the value as 0. In case of open drain configuration, we have to set the value as 1. The same thing you can observe it here. This, suppose we want to set this PA5, the same example we will see. PA5 we want to set in the output configuration. Then here we have to select, in this register we have to select the value of 0, 1, and next this output type register GPIO. You can observe its name, GPIO A underscore OT output type register. Its value, sorry, this is the value of this 11 and 10. So now here fifth port, that means at fifth pin, the value should be 0. Then it will be in push pull configuration. Okay. The next one will be output speed register. As I already told, this output speed, if we want to use for low speed, then the values will be 0, 0. In case of medium speed, 0, 1, high speed 1, 0, and very high speed 1, 1. Even though we have set the very high speed, it depends upon the frequency of the peripheral bus. Here the same thing they may have provided it here, you can observe. Note, refer to the device data sheet for the frequency specification and the power supply and load conditions for each speed. Okay, you can observe it here. The same thing I have explained. So even though we have set for very high speed, but the limitation will be present based upon peripheral bus speed. Okay. So now you can observe it here. Similarly, for the PA5, if we want to set, we have to set these values. If you want to set to high speed, then these values will be 1, 0. Okay. Next, as I told, that output particular pin if you want to enable as a pull up or pull down resistor, using this register value we have to set. Okay, you can see it here. This is the address offset, this is the reset value for port A, similarly for port B, similarly for other ports. Now you can observe it here. If you don't want to make any pull up or pull down, then you can set up as 0 0, or if you want to use as pull up, then you can set up 0 1. If you want to use pull down, then that register that particular bit value 1 0, and this 1 1 is for reserved. Suppose if I want to use as pull up, PA5 we want to use as pull up, then for pull up the values are 0 1. So in that case GPIO A underscore PUPDR register for a fifth pin, this is a fifth pin, so the values will be 0 1. So this 11th bit will be 0 and the 10th bit will be 1. Okay. Similarly, in case of input data register, see now, till now you can observe it here, all these pins are read and write options are present. Okay, but in case of input, as we are taking from the external, there is no provision for the write. So for this input data register, all the pins are only in read mode only, there is no write mode. Okay, so now you can observe it here, this GPIO port input data register. Suppose at the PA5 we want to make it as input data, this input data register we want to use, then at the fifth location we have to set this R value as 1. Okay, see you can observe it, sorry, we cannot set using this one, we can read that one. Suppose this value is 1, then this value we can read. See you can observe it here, these bits are read only, they contain the input value of the corresponding IO port. So we cannot set the values because that is input. Next, in case of output data register, we can both read what is the value of that output, and similarly we can write the value to that particular register. So you can observe the same thing at here. If you want to set that particular bit, then make it as 1. If you want to set that particular bit as low, then it will be 0. Okay. Similarly, bit set and reset register. This is the address offset for that register. And then you can observe it here, lower 2 bytes are using for setting the IO pin. You can observe it here. This from 0 to 15 are using for set purpose. Similarly, from 16 to 31 are using for reset. The same IO pin, to set we have to use this one, to reset we can use this. Next, it is about configuration lock register. Here, to lock the configurations of that particular GPIO port it is using. You can observe it here, you can read the description. And we have to set when the lock sequence has been applied on a particular port bit, the value of this port bit can no longer be modified until the next MCU reset or peripheral reset has been happened. So there will be one sequence will be present. We will see what is that sequence. See that particular bit we can set using it here, and this LCKK will be that lock sequence. See, this is that lock key and this is that lock key write sequence. So using this sequence we can lock that particular port, GPIO port. So next is about alternative function register. As I told, suppose that GPIO port we want to use for other purposes, then we have to set this alternative function value and then we have to use. Okay, so here if you observe, for each pin there are total 16 alternative functions are present. So maximum, this 16 is the maximum. So to set these 16 values, 4 bits we are going to use. But actually we have total, we have 16 pins, right? For each port 16 pins are present. So for each pin 16 means for each pin total maximum possibility of different alternative functions they are telling us they are using with 4 bits. So total 16 it will come. So total 4 bits. That means total 64 we need. So for that they are using 2 registers they are using. One register they are calling as low register, alternative function low register. Another register they are calling as alternative high register. So this is 0 to 31. Okay. And then high register also from 0 to 31. So here suppose PA5 if we want to use, then where it will come? So PA0 it will use from 0 to 3 because 4. PA1 it will use from 4 to 7, 4, 5, 6, 7. So 8. So like that PA5 it will be from 20 to 23. So this is the 24th bit. Suppose if we start from 0, then it will be from 20th bit to 23rd bit. Suppose if we want to set for PA15, then where it will come? It will come to the high register, because for the low register PA0 to PA7. For high PA15 to, sorry, it should be PX, any port, whether it is A or B or C or any port. So PX15 to PX8. Okay. So what are the different alternative functionalities? So you can go to this alternative functionalities and you can observe it there, like UART, I2C, SPI, all those will come under alternative functionality. In that UART, suppose TX, it will be using for the same pin which is having that GPIO and other functionalities also which it will support. Okay. So this is for low register. This is for alternate function high register. Okay. So next is about, if you want to do only that reset of that particular port register, then you can use this register, which is bit reset register. Okay. So now you can observe it here. This will be like a summary matrix of that one. So you can observe it here. This is the register bits from 0 to 31, because all are 32-bit registers, and that particular register and what will be its reset value. This reset value is maybe different for port A or port B and port C. We have already seen, right, in some functionalities port A reset value is different from port C reset value. Here it is same. It I will show. Here you can observe this pull up, pull down. See, this reset value for port A it is different, port B it is different, for other ports it is different, because these particular pins they are using for specific purpose. So that's why this reset value they have made like this. So this is the overall register map. This is what we have discussed till now. In case if you want to see what are the other alternate functionalities are present, then that alternate functionality map is also will be present. Let me check in the data sheet. See, now here you can observe the alternate functions. See, total for each port 16 pins are present. Those are these PA0 to PA15, and alternate functionalities they are set for 16 different alternate functionalities. So total 16 alternate functionalities are present. So to set that one, minimum 4 bits are required. So where is this alternate functionalities? Yes, now you can observe it here. Suppose, let me open it here. Suppose PA5 is there. Apart from GPIO port pin, why I am taking this PA5 means this PA5 is the where it connected to LD2. I have shown that LED, right? Wait, I will show. So this is the LED which is present, that is connected to PA5, I think. So because of that one, I am taking the example of that PA5. Suppose instead of as a GPIO pin, if you want to select with other functionality, then what are the other functionalities are present for PA5? This is for PA5. You can see these all are the other functionalities which we can use, like timer to channel 1, similarly timer to ETR, similarly SPI1 SCK, similarly you can observe it here, these two other functionalities also we can use. Similarly for other ports, for PB, port B, if we want to see, these are the alternate functionalities. Similarly for port C, for port D, like that for all the ports you can see the alternative functionalities, like till port G. Okay, remember that. Suppose for pin number 5, you can observe it here, this port G pin number 5 alternative functionalities are different from another port pin number 5. Okay, remember that point. So suppose now let us use for one value. Suppose this PA5 I want to use as timer to channel 1. Then which alternate functionality I have to set? I have to set the value of AF1. AF1 means, as we have discussed, this PA5 will come to the 20 to 23. So how to set its value? Let me write it here. So GPIO-A underscore alternative functionality lower register pin number 20, 21, 22, 23, which will be AF1. AF1 means 0001. So those particular pins should be 0001. Then we can use that one as timer to channel 1 pin. Okay. So these are the registers which are using to set for the GPIO. Once you can go through this reference manual and you can go through these data sheets and all. Okay. So now I will show the same, all these things what we have discussed now in the STM32Cube IDE. So now I am creating a new project. Now it is downloading some relevant files. Let it get downloaded fully. So now you can observe it here. Based upon microcontroller you can select, or based upon board selector you can select your particular board. Suppose if you, before purchasing the microcontroller or board, if you want to select which board is suitable for your application, then you can come to this MCU or MPU selector and then you can select your specifications. Suppose how many USBs are needed for your purpose. Similarly, what are the communication interfaces are required? Do you want CAN? Then you can select CAN. You want I2C. The minimum is 1. Suppose in my case I want total 3 I2C I want. Then I will select 3. So similarly CANs, UART, how many you want. So based upon that one, if you select, here you can observe this microcontroller, that list it is decreasing. So it will show what are the relevant microcontrollers with these features, all those things it will show. Suppose timers, so total 16-bit timers, similarly 32-bit timers, you can select these. So based upon that one, these microcontroller values and all it will get adjusted. Suppose ADC, I want 12 channel ADC. Similarly, suppose if I want 14-bit ADC converters also. So like that, based upon your requirements, you can select using this slider, you can select your requirements, then that particular relevant microcontroller it will display it here. And not only that one, you can observe based upon its package style and its flash memory and RAM memory, all those you can select. And if you want to export, you can export the data also. It will export to Excel. You can click on that, then it will ask where you want to save that one. Okay. So now in my case, I don't want all those things. As I know what is my board, I will try to type my board like Nucleo G474, or just type G474, different G474 boards it will show. So these four are the G474 boards. These they are showing it here. You can observe that device overview also how it will look like. In my case, I am using Nucleo G474. So see, observe here when I select this one, it is showing this one. Now let me select it here. It will show the small image of this one. In case if you want the bigger picture of this one, you can go to here and click on this bigger picture. Then you can see. Now let us try to see this LD2. See here, you can observe this is that LD2, which is connected to PA5. And in case if you want any resources regarding this one or presentations regarding this, you can go to it here and you can download, and product specification, schematic pack, all the documents which I have shown, I have downloaded from here. Okay. From here, the main very useful the things are reference manual and data sheet. If you want to download the data sheet, you can go and click it here. Then it will download the data sheet. Now I am starting my project, so click on next. And what will be my project name? Example is config check. Configuration checking is my project name. So I want to use the target language as C and executable type, and the targeted project type on STM32Cube. So it will ask, do you want to initialize the peripherals with their default mode? I want to say yes, then I am saying yes. Then it will render the MX UI interface. Okay, let it display, I will show. This is the MX UI interface. Here you can set all the things. Suppose, as we have seen, right, in the alternate function register, suppose you can see this PC file. What are the alternate functions you want to see? You can observe it here. Suppose, let me zoom this one. PC file, see here. Now you just compare with the alternate function register, which is PC5, right? So PC5, you can see these are the alternate functions. The same thing which will come at here. Similarly, PB14, PC5, PA5 by default, as it is connected to the LD2, so it has been enabled as output. See, GPIO output. In case if I want to connect that one as GPIO unlock, I can set this one. Suppose GPIO external input 5, I can set this one. So we have seen one configuration, right, for PA5. What is that one? Let me open the datasheet. For PA5, we have seen as timer to channel 1, correct? So now let me open this one and let us check that alternate function. You can see here timer to channel 1. Okay, now here in this MX configurations, when you select that particular configuration, then when it will generate the automated code. Okay, when it is generating that automated code, then that particular register values it will set based upon our selection. Okay, suppose if you select timer to channel 1, then it will set that AF1 value as 0001 yet from pin number 20 to 23 in the alternate function lower register, because PA5 is belongs to alternate function lower register. So now for time's sake, let me put to the GPIO output pin. Okay, like that, whichever port pin you want to set, you can set that particular port pin to that alternate functionality. Next we will see about clock configuration. So now before going to clock configuration, let me show you one more thing. Go to your system view and you can observe it here in the system core. Now what are the things has been selected, it will show it here in the system view. In the system core it has been selected this DMA and then GPIO and NVIC and RCC and sys has been selected, and in the connectivity low power UART1 has been connected. Using this LP UART only the communication will be happening. Okay, so now let me select this GPIO. I think it's already opened it here. Okay, see now here you can observe total 2 has been selected. One is PA5. You can observe it here, one pin is PA5, and when you select that one, see here you can observe the GPIO mode, output push pull configuration mode has been selected. Suppose if I want to change to open drain, then you can select it here, and you can observe it here. Whenever we are doing any configuration changes, here this particular pin it will blinks. Okay, next push pull configuration. Output level by default I want to set low, or if you want to set to high, then you can set as high. Similarly, pull up or pull down configuration. Here by default it is selecting as no pull up or no pull down. If you want to set to pull up, then you can set to pull up. See why we have to set all these things. Based upon our requirement we are setting these things, and manually we no need to go and change the values in the register. Okay, what this MX configuration it will do is it will generate that register values. Those values it will generate for those register, and it will set those values. And maximum output speed they have been set to low. And user label means you can observe it here. For this PA5 some label has been present. In case if you want to change that label, here you can type. Similarly PC13, you can observe it here, it is selected as a external input mode with rising edge trigger detection. So if you want to see about these external interrupts, then you can go to in the data sheet or in the reference manual, you can go to there and you can see about external interrupts. Okay, and similarly input pull up or pull down, no pull up and no pull down. For this user label they have set to this B1 blue push button. You can observe it here, the same name. In case if I change it here, here also it will change. Okay, next we will go for the clock configuration, and then we will generate that code. Now let me select this clock configuration. Now you can observe it here. What is the clock frequency of this our AHB? Our AHB clock frequency is same as this system clock, sys clock. Okay, system clock, which is 170 megahertz. From where they are generating, you can backtrace this one from PLL. They are taking from high speed internal RC clock. That RC clock value is 16 megahertz using PLL. That means using phase locked loop they are increasing that clock value to 170 megahertz. Suppose you want to change, suppose this AHB clock value you want to change to 16 megahertz, you can set to high speed internal RC clock. Or suppose in case external clock, in our case there is external clock is present. So let me show. So now you can observe it here. There are two clocks has been presented here. One is X2 and X3. One clock is 24 megahertz, another one is 32.768 kilohertz. Now let us observe the same thing here. See here, this is the 24 megahertz clock. So you can use, if you want to use HSE, then you can use HSE also. So it will take from the external, and this is internal to the microcontroller. That is this 32 kilohertz. Okay. Suppose As I told, our GPIO has been directly connected to our system clock. So our GPIO speed will be limited based upon this system clock value. Similarly, for different peripherals, if you want to set the clock values using this prescaler, you can set. Suppose here this APB1 bus is there. For this bus, I want to set the APB1 peripheral clocks as 6 MHz. I can set this prescaler as 4 and I can set that value. For timer, if I want to set, I can set. But here this timer, it is constant. If you want to change its value, you can change its value from this AHB prescaler values. Based upon that, you can set these timer values. Okay, like that, the entire clock configuration which they have provided in the data sheet, all that thing they have made as like a mathematical information. In a mathematical way they have set it here. The same thing it is present in the data sheet. Let me show that one. Now here you can observe, this is that clock tree. The same thing, to do these all mathematical things, instead of for us to do, the STM will come up with the STM MX configuration, clock configuration, that is this one. Okay, so based upon this prescaler value we can change it. This you can observe it here, this frequency values we can change. Similarly, instead of HSI, if I want to select PLL clock, instead of HSE, if I want to select PLL clock, then I can select PLL clock to provide the clock for this system clock. Okay, so now instead of us to manually go and set the values of the registers, you can auto generate the code. Now for that thing you can go to here, there will be one device configuration tool code generation will be present. You can click on that one, or go to project and then you can click on generate code, or click on Alt plus K. So now you can observe, for my project it is generating that code. Now you see, this is our project. In our project it has been generated one main.c, where it will be present. It will be present in the core. The core, in the sources, this main.c will be present. And there are some more folders also will be present. You can observe it here. There is one folder called includes. You can see that things. See, these all are the includes. So these are the includes. And then next, this is about the core, which will be our main project data will be presented here. And then similarly, this is the drivers. Now you can go to it here. In the two drivers will be present. One driver is related to our processor. Our controller is using ARM Cortex M4, right? So here if you go to this SIMSYS, see here CM4, this is, you can observe it here, SIMSYS Cortex M4 core peripheral access layer header file. Okay, so this is our, for our purpose, our controller, it is using this CM4. Remaining all things, if you delete also there won't be any problem, but this core underscore CM4 it should be present. And the next one is about HAL drivers. See, these are the place where we have seen about all those registers, right? So all those registers drivers, they are presented here in this HAL drivers. So here in the include you can go and you can open this GPIO.h. Here you can see all the things what we have discussed. See, pin, mode, pull, speed, alternate functionalities. So these things they are setting, they are used as a one structure. For that thing they have mentioned as GPIO init type def. So that's why in our main.c you can see that configuration GPIO init will be there. This is GPIO type def. So for declaring as GPIO, here you can observe init type def. In the initialization of this GPIO, they have declared this one. So it will be using this structure as like a one data type. So that's why they have used the concept called type def in C and then they have created this one. Similarly for reset and set, they have created one enum. So this reset value is 0, so the set value is 1. Similarly for GPIO pin 0, see this is that value for pin 0, for pin 2, pin 1, pin 2, this is the value. So using defines, they are declared that one. Similarly, now you can observe it here, these are the different modes which are present. So all those things you can observe it here. They have taken these external interrupt things also, that supportability, like rising, falling, all those things they have taken. And GPIO speed, which we have discussed, right? For low it will be 0, for medium it will be 0, 1, for high it will be 1, 0, for very high it will be 1, 1. Same thing we have seen in the data sheet, right? Let me open the data sheet. Set a reset output data. Yes, this is that speed. You can observe it here, that speed bits. What they have set, while writing the device drivers, they have written like this. Okay, and then similarly for pull up and pull down configurations. See here. Next, for setting that value for those registers, they have defined different things. You can go through this one and you can observe it here. See, along with that one, they have written some functions for initializing, similarly deinitialization functions, similarly for different operations, read pin, write pin, toggle, to lock that pin. See, external interrupt request handler, similarly for callbacks. Okay, if you want to see that functionalities and all, you can go to that its associated.c file and you can see its functionalities. Okay, suppose here this is for GPIO, this is for GPIO. Similarly for UART, then you can click on this UART and you can go through about this UART and all. This UART we are not covering in this free course. In the some other paid courses we are covering this UART also. Okay, now suppose this GPIO is there, I want to see what are the other functionalities are present. Now you can go to this side, one more pane will be present. You can observe it here, outline. In that outline all this data will be present, and here if you come to the down you can see that functions for GPIO init, dinit, these all are the functions which they have declared. Suppose if you want to see the functionality of read pin, see now you can observe it here. This GPIOX IDR, which is input data register. Okay, and that pin value they are seeing, and if that value it is set, then if that value is like not equal to 0, then that particular bit status is set. No, if that value is equal to 0, then that particular bit status is 0. Similarly for write pin also you can observe, you can come to know about here. See now for write pin they are using bit set reset register. Registers you can go through the datasheet and you can see using that same register value they will set it here. These all they will develop these things in the device drivers. So what is the need of these device drivers is, using device drivers they will create simple APIs. Now if I want to make any particular port pin, if I want to write as high or low, then you can go through its syntax and you can follow that one. We no need to go to that particular register and particular value, we no need to set that one. Okay, suppose here GPIO A, the same pin number 5, I want to set what is that state. You can see its syntax and you can set. The same thing we will do in our example program also. Example here you can observe it here. This is the syntax. See GPIO pin port A, pin number 5, they have made it as set, because in this configuration I have set that default value output as high. You can observe it here. See output level I just made it as high, so that's why this has been set as high. In case if I made it as low, then here see now I just made it as low, right? Now let me save that one. It is asking, do you want to generate code? Let me generate the code. Unsaved files, yes. Now you can observe it here in the initialization using this API call GPIO write pin API. They have made that value as reset. Okay. Similarly, you can observe it here that modes, pin mode and this pull up or pull down I just made as no pull up, no pull down. So that's why it is no pull up, no pull down. Like that they will set the things as this input they have made for the using external interrupts. So they have set that using NVIC they are setting that interrupt priority. Similarly, they are enabling that interrupt IRQ. Okay. Similarly, clock configuration also. You can observe all these clock configurations, how they have been set. All those things you can observe it here. This is in short about the full how to set the configurations in the STMcube IDE and fully about the GPIO port. What are the registers are present. This will be the in-depth knowledge. It will be required in case if you want to develop the device drivers or if you want to write the code, and if you want to optimize your code also, this knowledge is required. So in the next video, it will be like in short, the video will be present how to create that project and then how to set and reset and how to toggle the pins. Those things you can practice during the remote lab session. In case of any queries, you can take the screenshot of your query and in the caption you can write about your query and then you can post in the group. Then we will respond in the group. Okay. Okay then. Thank you to all.